Scientists just found a planet that shouldn't exist. This giant somehow survived next to an exploded star, one of the most extreme objects in the universe. And the deeper astronomers dig, the stranger it gets. The object orbits a pulsar. That's the collapsed core left behind after a massive star explodes into a supernova. A pulsar packs roughly the mass of our Sun, or 333,000 times the mass of Earth, into an object only about 12 miles wide. It spins hundreds of times every second, while blasting powerful beams of radiation into space. Anything nearby should have a very bad time, but somehow a planet is still there, and it's not a small one. The giant has roughly the mass of Jupiter, but almost nothing else about it looks normal. The planet circles its pulsar at a distance of only about 1 million miles. For comparison, Earth stays at about 93 million miles from the Sun. Because the orbit is so tight, a full year on this world lasts only 7.8 hours. The gravity there is so intense that scientists think it physically distorts the planet. Instead of a sphere, this world may be stretched into a giant lemon shape because of the pulsar's tidal forces. Then, the James Webb Space Telescope examined its atmosphere, and things got really weird. Instead of common molecules like water vapor, methane, or carbon dioxide, astronomers found unusual carbon molecules called C2 and C3. We've almost never seen such compounds in exoplanet atmospheres before. The planet may be wrapped in thick, soot-rich clouds made of carbon, and deep below those clouds, pressure could be so extreme that carbon crystallizes into diamonds. But the main question isn't even what the planet looks like, it's how it exists at all. Normal planets form around young stars inside huge disks of gas and dust. Pulsars are the opposite of young stars. They explode, flood space with radiation, and unleash particle winds powerful enough to tear nearby objects apart. So, such a close planet shouldn't be there. One possible explanation involves a rare class of systems called black widows. In these systems, the pulsar slowly erodes its companion with radiation and high-energy particles. Over millions of years, the smaller object loses more and more material, as if it's being eaten alive. PSR J2322-2650b may be the survivor of that process. But there's a problem. The chemistry still doesn't add up. Researchers think carbon crystals may form deep inside the object and slowly rise toward the atmosphere as the interior cools. But if that explanation is correct, scientists should see other elements too, especially oxygen and nitrogen. We don't even know what this object actually is. Part of it behaves like a planet, part resembles the remains of a large star, and one more part doesn't fit any known category at all. So for now, one thing is clear. PSR J2322-2650b doesn't fit any rules, and nobody knows what to do with it.
So planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, Their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot, it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP-18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers modeled how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, They say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all. This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises two theories. One suggests that Baekdu was once two stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the two stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system. The hunt for interesting exoplanets and life forms somewhere out there in the vast expanse of the universe keeps going. No stopping here. We're basically searching for a second Earth, a planet that's similar to our home, and where we could finally find some space friends. Hey, we're not picky. Any form of life is fine, even some bacteria-sized organisms. And this search has mostly been going on in the habitable zone around other stars. We call this the Goldilocks zone. That's a region where conditions are barely just right for liquid water to exist, whether we're talking about the surface of a planet or a moon. The hotter the star, the more space we get to explore, because its habitable zone spreads far away. And in terms of endless space that we yet know so little about, that's a lot of work. That's why we're fans of red dwarfs. There are hundreds of billions of stars in our galaxy, and probably around 80% of them are red dwarfs. These tiny stars are much cooler than our Sun. It means that their habitable zones are much smaller and closer to the star, so we know better where to look for planets. They're circling around their central star, and at some point, bingo, there it is. They pass in front of it and block out some of its light. The Kepler Space Telescope has already helped us find thousands of planets using this method, and most of them are orbiting around red dwarfs. Some of these planets are similar in size to Earth, and many of them could have nearly 25 times more water than our entire planet. Let's move to these planets scientists discovered, though. I want to show you something special. So, you've heard of super-Earths, right? More massive than Earth, lighter than Neptune, can be made of rock, gas, or a mix of both. Some of them have thick atmospheres, while others have thin or no atmospheres at all. You may also have stumbled upon mini Neptunes by now, too. They're almost as big as Neptune, and unlike normal gas giants, they have solid cores. That way, they can support a dense atmosphere with water and some other chemicals necessary for life. There's also hot Jupiters. Those are pretty cool, but only if they're far away from us. You know that one annoying and unpredictable neighbor you can never get rid of or figure out what they're going to do? Yeah, that would be a hot Jupiter, with strong gravity that can destabilize the orbits of smaller planets or other space bodies in the system. If we had such a neighbor, there would be more comets and asteroids hitting our surface. Luckily, our Jupiter's a good and peaceful neighbor that minds his own business, at least for now. But let's leave all these and many other planets out there alone now. Imagine traveling around in your spaceship and coming across a giant eyeball just floating there in the darkness of space and staring at the central star of that solar system. It's not a monster. Hopefully, space friends we'll make in the future won't look that big and scary, so it won't blink or turn towards you as you come closer. It's actually a planet. A little bit bizarre, but still very cool. And yup, you guessed it right, we call such eyeball planets. Now, eyeball planets are surprisingly common. Plus, some normal planets can potentially turn into them too. Eyeball planets form when matter and dust accumulates around a star and gradually turns into a solid object. It starts spinning, and over time, The gravity of the star pulls on the planet and slows its rotation until it becomes tidally locked. That means one hemisphere always faces the star, while the other is in darkness all the time. Now, we have a good example of this phenomenon near us, too. Our moon makes a circle around Earth once a month. It takes the same amount of time to turn a single time on its axis. That way, we actually always see the same face of the moon. Who knows? Maybe the other side is even prettier, if you like craters and stuff. So, one of the most interesting things about eyeball planets is their appearance. If they had water on their surface, the side facing the star would have clear, bright blue oceans, the ones we'd want to visit if we ever got a chance to go on an interstellar vacation. And the other side would be more for adventurers who like harsh and challenging surroundings. Since it's in constant darkness, it would most likely be very cold and covered in ice. We've discovered so many planets outside of our solar system in the last 30 years. Super-Earths are, of course, especially interesting. It seems that many of them are not that pleasant, since they're pretty hazy and cloudy. It means it's harder to spot any life there. But some scientists still think they're promising spots when it comes to finding life beyond our solar system. Eyeball super-Earths would be a good start. These planets are probably covered in large oceans. On the cold half, where the eternal night reigns, you'd experience Arctic conditions. I feel cold just looking at this. But the day side is my jam. Plus, it sounds promising when it comes to finding life. With all that sunlight, oceans, and stuff. One of the good examples where scientists are looking for life is an eyeball super-Earth that lies in a habitable zone of the closest star to our solar system, called Proxima b. Its day side could even have conditions and an atmosphere to support some form of life. There could be a large deep ocean covering its surface. It could be really salty, but some forms of life could still survive there. Check out the Dead Sea on Earth. It's extremely salty, but some bacteria have still evolved to live there. And they're probably doing well, having their own world and all that. It's not crowded because there are no animals there. Fish that accidentally end up in the Dead Sea won't survive there for long. So, similarly, it's possible that bacteria or some other forms of life could exist in this potentially very salty ocean on Proxima b as well. But the open ocean on Proxima b could be tricky. On the dark side of the planet, the ocean could freeze, and sea ice could drift into warmer waters. That way, the ocean would cool, and more of it would freeze, even on the sunny side. The only way to prevent this global freeze-over would be an atmosphere with a lot of greenhouse gases like carbon dioxide. This kind of atmosphere would trap the heat from the planet's surface and wouldn't allow it to escape into space, like what happens with Venus, the hottest planet in our solar system. Without an atmosphere with greenhouse gases, the surface of Proxima b would be much colder, so it's possible that the planet would completely freeze over. The opposite scenario could also be possible. Warmer waters could serve as a transporter of heat from warm to cold regions. We don't know much about the conditions on the planet yet, so Proxima b could range from a frozen wasteland to a hot, hazy world, depending on many factors. So yeah, an eyeball planet within the habitable zone sounds promising, but its surface can still wildly range from a frozen desert to an endless ocean. Some experts believe that drifting sea ice might cool many exoplanets out there, and they can't turn into eyeball worlds. Instead, many just become sad, dark snowballs, completely covered in ice. A cool spot to spend your interstellar winter holidays, but not a place where you'd hope to find life, unfortunately. Some studies show that even Earth may have gone through some snowball stages many times in history. One of those happened around 2.2 billion years ago. I wasn't around. While the other one hit the planet 630 million years ago. During these phases, all of our beautiful oceans were covered with snow and sea ice. Perhaps even the continents were just thick ice sheets, at least on the surface. Alright, enough with the freezy icy stuff. I need some hot chocolate. Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. there's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface. But if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. that's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler 22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler 22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler 22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler 22, the star of Kepler 22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler 22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler 22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler 22b is that it's about 15% closer to its star than we are to the Sun. If Kepler 22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler 22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler 22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler 22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler 22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler 22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler 22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler 22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler 22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler 22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler 22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler 22b. That would be awkward if it turns out to be a gas planet, or something like that.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. Koi 571501 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. Koi 3010.01. This planet is found next to the star Koi 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just one day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP-76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP-76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP-76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation. Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years. But finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda, yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
We have finally found out where our planet came from, and it's a revolutionary discovery. Earth might feel solid under your feet, but it started in a very different way. Billions of years ago, space around the young sun was packed with dust, rock, and metal fragments, flying at high speed. Everything was colliding, breaking apart, and sticking back together, and from that mess, Earth slowly started to take shape. But the big question has always been where all that material actually came from. Was Earth built mostly from nearby debris in the inner solar system? Or were some of its ingredients carried in by comets and distant asteroids? The process that built Earth is called accretion. That's basically a slow but brutal version of a snowball effect. Small particles clump together and form bigger rocks. Those rocks crash into each other, merge, and grow even larger. In massive high-speed impacts, things melt, shatter, and fuse again. Over time, about 30 to 40 million years, enough material piled up to form a young planet. Stuff that didn't get used in the process ended up as asteroids and meteorites. Scientists wanted to figure out exactly what kind of material built Earth and where it originally came from. If Earth's building blocks came from across the solar system, then our planet isn't just local. It's a mix of material from different regions of space. To understand that, they looked at something called isotope anomalies. tiny chemical differences inside rocks. Every chunk of space material has a unique signature based on where it formed. That's because the dust that created those rocks came from different ancient stars, each leaving behind slightly different chemical patterns. By reading these patterns, scientists can trace where a rock came from. They compared chemical fingerprints across different samples, meteorites that landed on Earth, fragments from the asteroid Vesta, and even pieces of ancient Mars. You see, space rocks fall into two different groups. One group is rich in carbon and often contains water. These rocks come from the outer solar system, far from the Sun. The other group has much less carbon. Such objects form closer to the Sun, in the inner solar system. This split likely happened very early, when Jupiter was forming. As Jupiter grew, its gravity became extremely strong and started to block material from moving freely through space. The gas giant acted like a barrier between the inner and outer solar system. Because of that, material from far away couldn't easily reach the inner region where Earth was forming. Studies showed that almost none of that outer material ended up in Earth. This means our planet was built mostly from nearby material about 4.6 billion years ago. And even though Earth contains many different elements, most of them came from the same region.
Hey, scientists may have just found a new planet that looks a lot like Earth, with a big icy catch. This world is about 150 light-years away, rocky, and circles a sun-like star on a schedule pretty close to ours. At first sight, it sounds promising, right? Well, slow down. There's a catch here. It might be insanely cold as Mars in the deep freeze. You see, HD 137010b, that's a mouthful, doesn't seem to be a gas ball, so we would probably be able to stand on its surface. It's a little bigger than Earth and goes around a star that's pretty similar to our Sun. This star is about 146 light-years away from our planet, which, in space terms, is close enough for scientists to study it instead of just, squinting at it. But what made people excited is the fact that this planet takes about 1 Earth year to go around its star. Now that's a big deal, because most exoplanets dash around their stars in days or weeks. Even better, this newly discovered one might sit right on the outer edge of the habitable zone, also called the Goldilocks zone. This region is not too hot and not too cold, which means that liquid water might exist on the planet if it has the right atmosphere. A big if, but still cool. Another thing that makes this planet extra special is how we see it. From Earth, it actually passes in front of its star. Imagine a tiny bug crawling across a flashlight beam. You got it. That makes it way easier for scientists to study things like its size, orbit, and maybe even what its atmosphere is made of. And if all of this checks out, it could be one of the best Earth-like planet candidates we've ever found. And now, the bad news. This planet does not get much sunlight. HD 137010b gets less than 1/3 of the heat and light Earth gets from the Sun. Even though its star is similar to our Sun, it's basically the Sun's quieter, dimmer cousin. Same type, lower wattage. What does that mean for the planet? It could be insanely cold. Scientists think the surface temperature might max out at around minus 90 degrees Fahrenheit. And that's not a grab-a-jacket cold, that's your face freezes right away cold. For comparison, Mars has an average temperature of around minus 85 degrees Fahrenheit. So this planet could actually be colder than Mars, a frozen desert, not to be confused with a frozen dessert, that looks like it gave up on life a long time ago. Another plot twist: this planet isn't officially a planet yet. At the moment, it's still labeled a candidate. Scientists usually confirm planets by watching them pass in front of their star over and over again. Every time that happens, the star dims just a little bit. But with this new space body, we've only seen one transit, a single 10-hour-long mini-eclipse, spotted during Kepler's second mission, called K2. Even with that one pass, astronomers could still learn a lot. They measured how long the planet's shadow took to cross the star, about 10 hours. For comparison, Earth takes about 13 hours to cross the Sun. Then, they plugged that into orbital models and estimated that the planet probably takes about a year to go around its star. That's impressive, but it's still not enough. Astronomers need to see that dip in starlight repeat on schedule to be sure it's really a planet and not some weird stellar wanderer. Unfortunately, this planet orbits far out, and those transits are rare. You don't get one every few days or weeks. You might have to wait a year or more for the next one. That's one of the big reasons Earth-like planets are so hard to find in the first place. So now, scientists are just hoping that other space telescopes can help out. NASA's TESS might catch another transit, or Europe's Cheops telescope could help pin it down. If neither of those catches it, we might have to wait for the next generation of space telescopes to get better data. Because even though this planet sounds like an ice cube in space, it's not totally doomed. If it has a thick atmosphere, especially if it's rich in carbon dioxide, it could trap heat really well, like a planet-sized winter coat. In that case, the planet might actually have a mild climate, or even liquid water on its surface. Well, based on computer models, scientists say there's about a 40% chance this distant world sits in the safe, conservative, habitable zone. A chance that is located in a more relaxed, optimistic habitable zone reaches 51%. But there's also a 50-50 chance that the planet is actually outside the habitable zone altogether. In other words, this planet is basically a cosmic coin toss. It could be a frozen wasteland, worse than Mars, a chilly, barely survivable world, or a watery planet hiding under a thick atmosphere. HD 137010b isn't the only place that has the potential to host human civilization in the future. In recent years, astronomers have been spotting new super-Earth planets orbiting remote stars. Now, checking our space vocabulary, super-Earth means a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. One of those planets is Gliese 667cc. It's just 22 light-years from Earth. But even though it seems pretty close, it's still around 129 trillion miles away from us. That's around 1.4 million times the average distance from the Earth to the Sun, so very, very far. The planet itself is around 3.8 times as massive as Earth, and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares from its parent star. Then there's Kepler 22b. This world is way farther away than the previous world, more like 600 light-years away from our planet. It's larger than Earth and is about 2.5 times our planet's size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is pretty similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kinda similar to our Sun. But this star is smaller and colder than ours. Now, don't confuse this world with Kepler 69c. It lies a whopping 2,700 light-years away from us and is almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 242 days to complete one orbit. This makes its position in its system similar to that of Venus in our solar system. At the same time, this world might be more hospitable than Venus since its host star is a bit less luminous, 80% of our Sun. As for our Venus, it's an extremely hostile place. You don't want to go there. A runaway greenhouse effect caused by an atmosphere that's about 96% carbon dioxide traps the heat. That pushes surface temperatures up to around 878 degrees Fahrenheit, which is hot enough to melt lead. On top of that, the air pressure is about 90 times stronger than that of Earth, and the whole planet is covered in thick clouds of corrosive sulfuric acid. Oh boy. Compared to our neighbor, TOI 733b seems like a pretty friendly world. This planet was found in 2023. It's floating 245 light-years away from Earth. The coolest thing about this planet is that it might have a massive ocean. According to scientists, this planet is likely to be completely covered with water. Does it mean there could be life on this super-Earth? Well, time will show. And who knows? Maybe soon we'll find even more planets that could become a new home for people looking to explore the universe. As for HD 137010b, the fact that it checks so many Earth-style boxes makes it a really interesting find. It's not a backup Earth yet, but it makes scientists stop and say, okay, this one's worth a closer look, or something similar. So get this. Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space, we're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the eRosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum. On August 20, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the 8th planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the 2 facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon.
For decades, textbooks treated it like a settled fact. Uranus and Neptune were ice giants. Strange frozen worlds made mostly of water, ammonia, and methane ice, hidden beneath thick atmospheres of hydrogen and helium. Now, scientists think that picture may be completely wrong. And the strange part is this. Humanity has barely studied these planets up close since Voyager 2 passed by them more than 30 years ago. That means one of the most basic ideas about our solar system may have been built on surprisingly little evidence. A new study is now challenging the traditional view of Uranus and Neptune. Instead of relying on old assumptions, researchers used computer simulations to generate thousands of possible versions of what these planets might look like on the inside, then compared them with the limited data scientists currently have.
The outcome was unexpectedly messy. Some models suggested Uranus could contain enormous amounts of rock. Others showed much larger quantities of water. Neptune's results varied just as wildly. In some scenarios, water dominated the planet's interior. In others, rock became the main ingredient. But the bottom line is that scientists don't really know what these planets are made of. The rethink started with an unexpected clue from the Kuiper Belt, the distant region beyond Neptune filled with comets, dwarf planets, and ancient leftovers from the early solar system. Scientists believe Uranus and Neptune formed from the same raw material that still exists in that region today. So when newer observations revealed that many Kuiper Belt objects, including Pluto, contain far more rock than expected, it created a major problem for the traditional ice giant theory. If the material that built these planets was already rocky, then maybe Uranus and Neptune are far rockier than scientists originally thought. To explore that possibility, scientists simulated the extreme conditions hidden deep inside giant planets. The pressures there are millions of times stronger than anything experienced on Earth, combined with temperatures so high that matter begins behaving in very unusual ways. The models produced another surprise. Rocky materials, known as silicates, may not stay trapped deep in the core. Under enough pressure and heat, they could spread upward into the atmosphere itself, mixing with hydrogen and helium and forming enormous silicate cloud layers. If that idea is correct, Uranus and Neptune may have much more in common with rocky planets than anyone expected. Researchers are now questioning whether the term ice giant still makes sense at all. Some scientists believe these worlds may need an entirely new classification, with names like small giants or even rocky giants replacing the old label. For scientists, that shift would affect far more than terminology. It would completely reshape our understanding of how planets form, how the outer solar system evolved, and how many other worlds across the galaxy may have also been misunderstood. For the rest of us, it changes something simpler. Two planets we thought we understood suddenly became mysterious again.
3, 2, 1, 0.
In 1977, NASA sent the Voyager spacecraft to explore the outer parts of the solar system and the space beyond. And at one point, the probes ran into something totally nightmarish, a blazing wall of fire measuring temperatures from 54,000 to 90,000 degrees Fahrenheit. Well, did the probes manage to survive these intense conditions? We'll find out soon. Meanwhile, there are several ways to think about where the solar system ends. One way is to say it ends where the planets stop. Another way is connected to the Oort cloud. That's a giant group of icy objects far beyond the planets, the farthest region of the solar system. It is extremely distant, maybe a quarter to halfway to the nearest star. To understand such huge distances, scientists often use something called the astronomical unit, or AU. 1 AU is the distance between Earth and the Sun. For comparison, Pluto orbits between about 30 to 50 AU from the Sun. The inner edge of the Oort cloud is thought to be much, much farther away, and the outer edge could be even further away. These distances are very hard to imagine. My little brain sputters when considering such. Now, we can also measure them in time instead of miles. NASA's Voyager 1 spacecraft makes almost 1 million miles per day. At that speed, it would take about 300 years to reach the Oort cloud and maybe 30,000 years to reach its outer edge. Now, one more way to define the edge of the solar system is by the Sun's gravity. It might be the area where the Sun can still pull objects back toward it. And finally, we can define it by considering the heliopause, the boundary where the Sun's influence ends. You see, the Sun constantly sends out charged particles in a flow called the solar wind. This wind moves past all the planets and reaches about 3 times the distance to Pluto. The solar wind creates a giant bubble around the Sun and planets called the heliosphere. The heliopause is the outer edge of this bubble, where the solar wind meets the wind coming from other stars, called the interstellar wind. Here, the pressures from the solar wind and the interstellar wind balance each other. This causes the solar wind to turn back and flow along the tail of the heliosphere. As the heliosphere moves through space, it creates a bow shock, similar to the wave that forms in front of a ship moving through the water. So, depending on how you define it, by planets, by the Oort cloud, by gravity, or by the Sun's magnetic influence, the edge of the solar system can mean very different distances. But if we talk about the Voyagers, they came across something intense. It was something we could probably call a wall of fire. Blazing heat and intense temperatures. The two probes became the first spacecraft to travel beyond the heliosphere and cross the heliopause. Before the Voyager spacecraft reached the heliopause, scientists did not know exactly where this boundary would be. But the fact that the two spacecraft crossed it at different distances helped confirm some predictions about the heliopause. Scientists did expect that the edge of the heliosphere could move as the Sun's activity changes, a bit like a lung expanding and contracting as we breathe. And the fact that Voyager 1 and Voyager 2 encountered the heliopause at different distances matched this expectation. The heliopause is not a hard edge or solid wall, but the nickname Wall of Fire actually matches the nature of that insane region. Both spacecraft measured extremely high temperatures there, around 30,000 to 50,000 Kelvin, or 54,000 to 90,000 degrees Fahrenheit. Despite these extreme temperatures, the spacecraft were safe. The particles in this region are very far apart, so collisions are rare and not enough heat could reach the spacecraft to harm them. Nearly 50 years after their launch, Voyagers 1 and 2 continued to send back data from beyond the heliopause. They are the only two spacecraft that have crossed this boundary so far. Together, they have already made several curious discoveries about space outside the solar system. For example, Voyager 2's magnetic field measurements confirmed a surprising result from Voyager 1. Just beyond the heliopause, the magnetic field lines are aligned with the magnetic field inside the heliosphere. Before Voyager 2, scientists only had one measurement from Voyager 1, so they could not be sure whether this alignment was real or just a coincidence. Voyager 2 confirmed that the alignment was real. The magnetic fields inside and just outside the heliopause apparently run in parallel. These discoveries give scientists important information about the structure and behavior of space beyond the solar system. Now, let's dig a little deeper into the Voyager program itself. It's made up of two spacecraft, Voyager 1 and, wait for it, Voyager 2. Even though Voyager 2 was launched first, in August 1977, Voyager 1 took off just 2 weeks later on a faster, more direct path. These two spacecraft have been traveling for more than 40 years, exploring worlds no human will ever walk on, at least in the near future. The two Voyager spacecraft are nearly identical. Each has a large radio dish that is 12 feet across. This dish sends data back to Earth. They also have 16 thrusters to control their direction and make sure the dishes always point toward our planet. The thrusters use special hydrazine fuel, and the spacecraft's electronics are powered by thermoelectric generators that run on plutonium. Each Voyager carries 11 scientific instruments. About half of them were made specifically to study planets, and most of those are now turned off. The turned-off instruments include several cameras, spectrometers, and 2 radio-based experiments. During their long journeys through the solar system, the Voyagers took tens of thousands of images and measurements. This data has changed what we know about the outer planets. When the Voyagers reached Jupiter, they gave us our first detailed look at the planet's atmosphere. They showed that the Great Red Spot was a huge storm spinning counterclockwise and interacting with smaller storms nearby. The Voyagers also discovered a faint dusty ring around Jupiter. They studied Jupiter's moons, too. They found volcanoes on Io, saw linear features on Europa that hinted at a hidden ocean beneath its icy surface, and confirmed that Ganymede is the largest moon in the solar system, larger even than Saturn's moon Titan. Next, the spacecraft flew past Saturn. They measured the planet's atmosphere and studied its famous rings, discovering gaps and waves we still see today. Voyager 1 looked through Titan's thick haze and suggested that the moon might have liquid hydrocarbons on its surface. It was later confirmed by other missions. Voyager 1 also found 3 new moons orbiting Saturn: Atlas, Prometheus, and Pandora. So that's where she ended up. After Saturn, Voyager 1 continued out of the solar system, while Voyager 2 headed toward Uranus. Voyager 2 discovered 11 new moons and 2 new rings there. It also observed strange features, such as Uranus's unusual magnetic field and a surprisingly small temperature difference between its equators and poles. Voyager 2's final planetary stop was Neptune. It happened 12 years after leaving Earth. There, it discovered 6 small moons and rings around the planet. It studied Neptune's atmosphere and magnetic field, and observed volcanic vents on Triton, Neptune's largest moon. After this, Voyager 2 joined Voyager 1 on its journey toward interstellar space. Voyager 1 entered interstellar space in August 2012, and Voyager 2 joined it in November 2018. These missions helped scientists measure the edge of our solar system, about 11 billion miles from the Sun. The spacecraft still sends back data about this mysterious region. By the way, after its planetary visits, Voyager 1 took the famous pale blue dot photo of Earth from about 3.7 billion miles away. Today, Voyager 1 is about 15.8 billion miles from Earth, and Voyager 2 is about 13.1 billion miles away. Each Voyager carries a golden record, a time capsule from Earth for other civilizations it might meet. The record covers include instructions for playing it, a map showing Earth's location, and a drawing of a hydrogen atom. The records are cleverly plated with uranium, so the decay of the uranium could help discoverers figure out when the record was made. The records contain 115 images showing Earth, humans, animals, plants, and our solar system. They include natural sounds like waves and birdsong, greetings in 55 languages, brainwave recordings, and a mix of music, ranging from Beethoven to Chuck Berry and folk songs. Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really. It suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. The joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky. Folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fault protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.
We also might have just stumbled upon the mother of all water reserves, floating in space. And it's been hiding under our noses for at least around 12 billion years. As for its size, it's hard to even imagine. 140 trillion times larger than all the oceans on our home planet combined. This cosmic water world is orbiting around a large black hole known as a quasar, located 12 billion light-years away. Quasars feature supermassive black holes, spewing out colossal quantities of radiation. This one in particular is estimated to be 20 billion times heavier than our Sun, and carrying energy that could outshine 1,000 trillion of them. Here in our cozy Milky Way, we're used to seeing water in ice form. This water reserve in particular seems to be in the shape of vapors. The important thing about this discovery is that there may be water everywhere in the universe. We just need to learn where to look. You might be surprised to learn that not all stars are hot to the touch. We used to think all stars were like our Sun, these blazing hot balls of fire, ready to melt anything in their path. Their cooler counterparts are called brown dwarfs. What makes them special is that they're too small to pull off the nuclear fusion that keeps stars like our Sun shining. They don't give off much light or heat, which makes them hard to see. These brown dwarfs are also split into different categories. There's this one group called Y-type stars, and they're the coldest, with a surface temperature lower than your average cup of tea. If you could reach out and touch one, you'd probably just feel a cozy warmth. Around 4 billion years ago, Uranus apparently switched places with Neptune. It's hard to imagine planets that big doing that, but this theory might solve the mystery of how our solar system came to be. We know that rocky planets formed after big collisions. Take our planet for instance. Around 4.6 billion years ago, things kept bumping into each other around the Sun until our watery Earth reached its final form. It also included one larger collision that blew up enough rock and gas for it to generate our Moon. But when it comes to our larger solar system neighbors, Jupiter, Uranus, and Neptune, scientists still haven't got an answer. Standard models said it'd take forever for them to form, way longer than the solar system itself has been around. If this new theory is correct, it suggests that Uranus and Neptune came from this dense cloud of gas compacted around the Sun. Problem is, for the theory to make sense, they had to have swapped places at some point in history. Neptune is about 2.8 billion miles away, the farthest any planet can be in our solar system. Uranus is a bit closer, located at 1.9 billion miles. This new idea suggests that after they formed way closer to the Sun than they are today, their positions were altered. It could have either been because of many comets passing by over billions of years, slowly tugging the giant planets away. It's not a definitive answer to how gas giants were formed. It's more like a strong hunch backed up by looking at a lot of numbers. Speaking of weird things found in our universe, what about this floating spoon that NASA's Curiosity rover took a picture of on Mars? As the machine was cruising around the red planet, it stumbled upon this oddly spoon-shaped rock during the summer of 2015. The rock has a handle and even throws shade on the ground. It's not a leftover utensil from some Martian picnic, but rather what NASA scientists call a ventifact. That means it's a rock that got sculpted by the wind. It's not the first time the Martian surface has delighted us with weird, windy sculptures. There was the face on Mars, a rat, and even jelly donuts. It's also possible that diamonds are raining down on over 1,900 exoplanets out there in space. Scientists found out that you don't need particularly hot temperatures for carbon to turn into diamonds, like it was previously believed. Up until recently, we only knew of Neptune and Uranus to potentially feature sparkling showers. Astronomers were onto this interesting phenomenon for about 4 decades, but these planets were hard to study. We've only had one space mission, Voyager 2, swing by for a peek. A lot of progress is being made though, thanks to lab simulations. Neptune and Uranus are called the ice giants because their outer layers are filled with hydrogen, helium, water, and ammonia, what scientists call ice. And that gorgeous blue hue they have is due to the methane in their atmospheres. The beautiful diamondy phenomenon happens deep down, however. If we could visit, we would see that beneath the thick atmosphere, there are layers of very dense ice. And under all that pressure, chemical reactions are happening, possibly generating diamonds the size of a small town. We can't just dive into Neptune or Uranus with a diamond-seeking probe. Instead, the same conditions are being replicated in labs here on Earth, squeezing matter between diamond anvils and zapping it with lasers to mimic the extreme conditions. Under these circumstances, scientists managed to create artificial diamonds. Understanding how these rocks formed down there could also explain why Neptune is hotter than it should be, and why it's got such intense storms. These diamonds might also be the key to unlocking the mystery of Uranus and Neptune's weird magnetic fields. If we compare it to our planets, it doesn't behave the same way, so there may be weird things happening under the surface to affect the magnetism. NASA's plans include sending a new probe to Neptune or Uranus in the next decade. With the planets aligning just right in 2030, it's the perfect time to explore these potentially diamond-filled worlds up close. Planet Kepler 78b is another weird cosmic discovery. It's a hot, molten world that's doing laps around its star in record time, once every 8.5 hours, and pretty close, less than 1 million miles away. Hot environments aside, if we could set foot on its surface, we'd notice its sun being 80 times larger on its sky than the daily view we have here on Earth from our star. If we apply what we know so far about how planets form, this little guy shouldn't even be there. Specialists still don't have a clue how it came to be or how it ended up where it is now. What we do know is that it will disappear soon. Sort of. Since it's so close to its start, this scorching hot planet is going to collide with it in a couple of billion years. Sounds like a lot, but it's a cosmic jiffy. What's similar between our planet and Kepler 78b is the density. Sure, it's about 20% bigger than Earth and weighs almost double, but it's got that same solid interior. There's no possibility of it forming any closer to its star and simply moving away with time. It also couldn't have been born much further away and migrated in. Any movement inward would have been unstoppable, and it would have also collided with the star.
This may not be a particularly groundbreaking discovery, but chances are you've never thought of it. There may be space dust in your hair right now. Every day, loads of outer space matter comes raining down on Earth. Sometimes we get flashy objects, like when a meteor turns into a meteorite by crashing down to the ground. But most of the time, it's quieter. This cosmic material drifts down through the atmosphere, landing softly as what we call space dust. It may not sound like much, but it does add up to around 14 tons every single day. This space dust contains tiny fragments of rock and metal, broken off from asteroids and comets during big collisions. These particles are very small. You can't see them without special tools. But every time you step outside, some of it might land in your hair.
All the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20th, 1977, thousands of people gathered outside NASA's Kennedy Space Center. They came to witness the launch of the most ambitious and distant space mission in history. 5, 4, 3, 2, 1, ignition! Launch rocket Titan took off from Earth and left the atmosphere. As soon as the rocket reached outer space, it launched the probe Voyager 2, which began its journey. The probe consisted of a bus 1.5 feet in height and almost 6 feet wide. On top of it, there was a round 12-foot wide antenna. Most of the scientific equipment was mounted on a boom that extended 8 feet outward. On September 5, 1977, Voyager 1, the identical space probe, left our home planet. It sent us pictures of Earth and the Moon. It soon overtook Voyager 2, launched 2 weeks earlier. That's why the second probe has the number 1 in its name. And so the journey through dark space began. March 5, 1979. About 4 Earth-Sun distances away from our planet, Voyager 1 came close to Jupiter and prepared its scientific equipment to explore the planet. The probe had a dozen gadgets, including a 2-camera system with narrow and wide-angle lenses. So, it could take full-length photos of the planet with the wide-angle camera, as well as close-up photos of specific places on the planet and its satellites. The probe also had a radio science system to determine the atmospheric composition, weight, and gravitational fields of the planets it came across. Infrared and ultraviolet spectrometers could help measure radiation and temperature invisible to the human eye. Various sensors were used to examine cosmic rays. Voyager 1 was the first to find volcanoes outside Earth. Those were on Jupiter's satellite, Io. It has dozens of active volcanoes that constantly spew lava. Then the probe pointed its cameras at the Great Red Spot. That's how people learned that it was a giant cyclone-like storm that hasn't stopped for the entire history of observations of Jupiter. It was also the first time when lightning was detected outside of our home planet. And in the invisible spectrum, Voyager 1 noticed that Io acted like an electrical generator for Jupiter. Ions, which are charged particles, were constantly flying toward the gas giant. This electrical current was 5 million amps. Soon, Voyager 1 continued its journey. 5 months later, Voyager 2 approached Jupiter too. This gas giant has rings around it. They're not like Saturn's though. Jupiter's rings consist mostly of dust. When the planet's rocky satellites collided, they turned into small debris. Gradually, this debris turned into fine dust. Then Voyager 2 approached Europa. This moon is completely covered by a crust of ice, and beneath it, there may be a liquid ocean where life can possibly exist. Voyager 2 was the first to capture the cracks in Europa's ice crust. While flying near Io, Voyager 2 discovered that 6 volcanoes on its surface were still erupting. This meant that the periods of activity of these volcanoes could last for months. Both space probes circled the gas giant several times and then dashed further into space. Such a gravitational maneuver allowed them to gain more speed and saved fuel for the trip. By November 9th, 1980, Voyager 1 had already traveled 8 Earth-Sun distances away from home. the space probe arrived at Saturn. It discovered 3 new satellites of the gas giant: Atlas, Prometheus, and Pandora. This proved the theory that these were the moons that kept the planet's rings in line. It also turned out that unlike Jupiter's, Saturn's rings also contained ice. Voyager 1 took a peek at Titan, Saturn's largest satellite. It's 50% larger than the Moon and even has an atmosphere. It's the only place in the solar system besides Earth where liquid water has been proven to exist. That's why scientists don't deny the possibility of life there. Then it was time for another gravity maneuver. Voyager 1 once again darted away from the planet's orbit. This time, it was aiming upward relative to the line of the parade of planets. Almost a year later, Voyager 2 arrived there. It made a flyby of several of Saturn's icy satellites. Supposedly, a long time ago, these moons collided and knocked huge chunks of ice and rock out of each other. This debris orbited Saturn, collided, and slowly crumbled into dust, consisting of ice and rock. This is how the famous rings of Saturn were born. Another gravity maneuver, and Voyager 2 set off for the next gas giant. 5 years later, it arrived at its destination, 17 Earth-Sun distances away from our planet. For the first time ever, a human-made object approached Uranus. Voyager 2 discovered 11 new moons there. The probe also found that Uranus was the coldest planet in the solar system. Its temperature is negative 350 degrees Fahrenheit. That's 4 times colder than the temperature at the South Pole. At that time, the Deep Space Network was being tested on Earth for the first time. It's a network of radio telescopes all over the planet. They aim at certain points in the sky to establish communication with extremely distant objects. These telescopes have been successfully receiving signals from Voyagers 1 and 2. August 25, 1989. Voyager 2 had already traveled 23 Earth-Sun distances and arrived at Neptune. It was the first time people received images of this blue planet from such a close distance. The probe discovered 6 new moons there and also took the first pictures of the planet's rings. Engineers then turned off the probe's cameras to save power for its main computer and the instruments that measured the solar and interstellar wind. Voyager 2 left Neptune and headed into deep space. That's why it no longer needed the cameras. A few months later, Voyager 1 sent its last photo back to Earth. It was a family portrait of our entire solar system. Every pale dot was a planet. You can barely recognize Earth in the picture. After that, the camera was turned off to save power. This was the start of the interstellar mission for Voyager 1. For 15 years, Voyager 1 had been flying to the edge of the solar system. On December 16, 2004, the probe passed through the termination shock. This is where the solar wind suddenly slows down and heats up after colliding with the interstellar wind. The space probe managed to endure this test and continued its journey. In 2007, Voyager 2 crossed the same boundary. At that point, sensors recorded a temperature of about 266 degrees Fahrenheit, but the probe managed to withstand it and continued its journey through the dark cosmos. Both Voyagers moved through interstellar space in different directions. They discovered that the heliosphere, the solar wind bubble, is not perfectly round, but more like an egg. August 25, 2012. Voyager 1 became the first human-made object to enter interstellar space. It's now also the most distant artificial object in human history. On November 5, 2018, Voyager 2 also left the solar system. The 2 probes continued their journey into deep space. Right now, the Voyagers have been operational for 44 years. Voyager 1 has traveled 153 Earth-Sun distances and is moving forward at 38,000 miles per hour. In about 300 years, the probes will reach the Oort cloud. This is a hypothetical region around the solar system with nothing but asteroids and blocks of ice. Scientists believe they might reach the nearest stars in the next 40,000 years. Perhaps one day, the Voyagers will enter these star systems and explore unknown worlds. There may be planets there that look like ours. The probes may even be able to find an intelligent civilization there. For this purpose, each Voyager carries a golden record with a message on it. There are 115 images. Among them, there's our number systems, a map of the solar system and pictures of its planets, diagrams of human DNA, portraits of people, and landscapes from Earth. There's also greetings in 55 of Earth's languages, including the oldest and newest of them. There are also 90 minutes of music from every corner of our planet. The Voyagers also carry a device to play these sounds. If another civilization gets this record, their scientists could decode the data step by step. And then, that civilization may decide to pay us a friendly visit. They'll have to repeat the heroic journey of the Voyagers, though. Dozens of light years through dark space. Then crossing the border of the solar system, and finally flying past Neptune, Uranus, Saturn, Jupiter, Mars, and the asteroid belt toward the little blue planet. We can only hope that people will be advanced enough to welcome them.
Beneath the frozen surface of Uranus's moon, Ariel, something massive may be hiding, an ocean more than 100 miles deep. That's 40 times deeper than the Pacific Ocean, and it's been sealed up under ice for billions of years, waiting to be discovered. So Uranus is this pale blue gas giant way out there, the loner planet that never gets much attention. But recently, scientists turned their telescopes and computer models toward one of Uranus's 29 known moons, Ariel. Compared to its sisters and brothers, Ariel's got quite a unique personality. When the Voyager 2 spacecraft flew by in 1986, it caught some photos showing an oddly smooth surface peppered with craters, fractures, and valleys. Those details might not sound exciting until you realize what they mean. This moon was geologically active, moving, cracking, and reshaping itself like Earth does. That's rare in the outer solar system, where most moons are just frozen popsicles, quietly spinning around their planet. When scientists studied those fractures, technically called grabens, they found something strange. The pattern of these cracks looks exactly like what happens when there's pressure building underneath the surface, like a balloon stretching before it pops. It's as if something deep inside Ariel was pushing outward, warping and breaking the crust. The most logical culprit would be a subsurface ocean, which was once warm enough to push against the icy layers above it. An ocean sealed under miles of ice, hidden for billions of years. So, how would something so far from the Sun even have liquid water? Well, Ariel's orbit isn't perfectly circular, but slightly oval, which scientists call eccentric. That means as it circles Uranus, the gravitational pull changes a little each time. The constant tugging stretches and flexes the moon's interior, creates friction, and voila, generates heat. Combine that with natural radioactive decay inside the rocky core, and suddenly you've got enough warmth to melt ice deep below the surface. So Ariel might have been making its own geothermal spa out there in the middle of nowhere. Scientists modeled its interior structure and found that the stress the tidal forces were causing could have kept liquid water stable for millions, maybe even billions of years. Even cooler, or warmer in this case, is that traces of that ocean may still exist. Ariel's icy shell shows features that look recent, geologically speaking. That means the moon hasn't been completely frozen for all eternity. Beneath those fractures, there could still be small pockets or thin layers of liquid water. And this brings up the most exciting part. Water means potential life. Every time scientists find signs of liquid water somewhere in the solar system, they start whispering that question we all secretly love. Could something live there? Sure, Ariel's no tropical resort, but remember, on Earth, we've found microbes thriving near hydrothermal vents at the bottom of our oceans, living off chemicals, not sunlight. If Ariel once had similar vents pumping heat and minerals into its ocean, it could have easily hosted its own microscopic residence. And if there was an ocean there once, it could still have salt in its interior. Scientists believe salts and ammonia could act like antifreeze, keeping the water liquid longer. So even though the surface temperatures drop to minus 351 degrees Fahrenheit, the inside could stay cozy enough for water to remain unfrozen. Now, before you start packing for Uranus, let's remember this is a moon orbiting a gas giant that's about 1.8 billion miles away from us. Visiting it isn't as simple as booking a plane ticket. Voyager 2 is the only spacecraft that's ever gotten even close, and that was almost 40 years ago. we have better photos of Mars's sand dunes than we do of most Uranian moons. So, for now, scientists rely on clever modeling, telescope data, and a lot of patience. Still, this discovery is big. For decades, we've looked at moons like Jupiter's Europa or Saturn's Enceladus as the best representatives of the ocean world category. They're icy, they have subsurface oceans, and scientists have actually detected water plumes jetting into space from them. But now Ariel joins the club. If we ever send another mission to Uranus, Ariel would be a prime target for exploration. Now, another destination worth checking out is Saturn's moon, Mimas. Scientists have always thought it was just a frozen rock ball, but it might be hiding a whole ocean underneath its surface, and a future spacecraft could find it. Researchers have been mapping how thick the moon's icy crust is, and those maps help them figure out how old this ocean could be and where the ice is thinnest. That's the jackpot spot for future missions to check for liquid water. Mimas doesn't look like a typical ocean world. When you look at Europa or Enceladus, you can literally see the cracks and crevices in their icy shells. Mimas looks smooth and quiet, almost like a cue ball in space. The craters look permanent, carved in rock rather than ice. Nothing about it screams ocean world. But a few years ago, data from NASA's Cassini spacecraft started telling us otherwise. Cassini, the probe that gave us our best tour of Saturn and its moons, kept sending back info that didn't quite make sense unless Mimas had liquid water under all that ice. The more Cassini's data rolled in, the more it looked like there might be a newborn ocean hiding under 12 to 19 miles of solid ice. Scientists used models originally made for Europa to figure out how heat moves through Mimas's icy shell. They wanted to know how thick it was, how much heat it could trap, and whether it could melt ice below. And they found that once melting starts on Mimas, it doesn't stop. It accelerates, and really quickly. All that melting ties back to Mimas's orbit. The Moon doesn't orbit Saturn in a perfect circle. Its path gets a little stretched. That oval shape means the Moon gets pulled and squeezed by Saturn's gravity as it orbits. The same way the Moon's gravity gives us tides here on Earth, Saturn's gravity tugs on Mimas. But instead of water tides, it's flexing solid ice. And that flexing creates heat. So, at some point, something kicked Mimas into a slightly weirder orbit, maybe a collision or a gravitational nudge from another moon. The inside of Mimas heated up, melted some of its ice, and created an ocean under the surface. But then, gravity slowly started to pull Mimas's orbit back into a circle again. When it does that, the heating will stop, and eventually, the ocean will freeze all over again. So basically, Mimas is in its warm ocean-having phase right now. Computer models show that the orbital change probably happened just 10 to 15 million years ago. That's nothing in space-time. It also turned out that the heat on Mimas doesn't move in a simple straight line. It kind of loops and twists, depending on how thick the ice is, which means finding this ocean won't be easy, but it's not impossible. Studying possible ocean worlds, and the ones of which we already know for sure, like Europa, Enceladus, Titan, and Callisto, is crucially important for us down here on Earth. Every time humans find liquid water somewhere new, we're basically discovering another version of the one thing that made us possible. Earth's oceans gave birth to everything alive, including us humans. When scientists learn how Europa's or Enceladus's oceans stay liquid without sunlight, they learn something about Earth's deep sea vents, about heat and balance. When they model Titan's chemistry, they're basically looking at what Earth might have been like before life began. So maybe life isn't that rare, and one day a probe will dip into the icy ocean of Europa with NASA's Europa Clipper, or scoop up water from Enceladus's geysers and find something, even a single living cell. And when that happens, it'll rewrite everything we think we know about life. It'll also remind us we're not the center of the story. but just one chapter in a universe full of water. Well, apparently Earth may not be the only place where you can have a glass of water. Scientists found one more world that looks very promising, because it might have liquid water on its surface. Even Mars can't compete with that. This planet is not too far from Earth and orbits a star called JG 887. Look, this is Earth and this is the Sun. Zooming out, see this speck of light? It's this star we're talking about. This star is 10.7 light-years away from ours. For comparison, Earth is way less than 1 light-year away from the Sun. And a spacecraft could get us to the Sun in a few years. But with our modern technologies, we would need over 270,000 years to get to that star system. And still, that's close, by space standards of course. Scientists call the planet a super-Earth because it's bigger than our planet, more than 6 times the mass of Earth. That's heavy enough to have strong gravity and a thick atmosphere. Another interesting thing is that, unlike many stars of its type, GJ 887 doesn't flare up much. Big stellar flares can blast away a planet's atmosphere. The fewer flares there are, the better chance a planet has of holding on to air, water, and maybe even life. When astronomers talk about the habitable zone around a star, they mean a spot that is not too hot and not too cold, where water could exist on the surface. But water isn't just about temperature. You also need air. Without an atmosphere, any water would evaporate or boil away instantly. According to researchers, the star's planet, JG 887d, might actually have an atmosphere, which makes it a true habitable zone planet. Now, scientists already found 2 other planets around the same star back in 2020. But both were too close to the star, way too hot for liquid water to survive on their surfaces. The research also hinted at a 3rd planet around this star. But at first, scientists weren't completely sure it was real. They thought the data could have been a fluke or weird blips in the measurements. But after 5 more years of watching the star, the planet was confirmed. It orbits its star every 51 days or so you'd celebrate your birthday once every 51 days there. It's even shorter than a year on Mercury, which means the planet is very close to its star. Then why doesn't it burn up and could even host life? The thing is, the star, GJ 887, is smaller and dimmer than our Sun. That's why it doesn't blast this 3rd planet with heat. So even with a shorter orbit, the planet's temperatures should be only a little warmer than those on Earth. Now, the good news is that the conditions on this new super-Earth might actually allow water to pool somewhere instead of evaporating immediately. No wonder this discovery is a big deal. For one thing, we might finally find life beyond Earth. Because where there's liquid water, there's a good chance of life. Plus, if we ever had to leave Earth, GJ 887d could be a strong contender for our new planet. Now, one big problem for planets around small stars is flares. Many red dwarfs blast their planets with intense bursts of radiation, stripping away any atmosphere. Without air, water can't stick around, and life doesn't have any chance to survive. That's probably why Proxima b, the nearest planet outside our solar system, likely has no atmosphere at all. But GJ 887 is unusually calm. It doesn't flare like other small stars. Of course, this might just be temporary, or it could last for billions of years. Either way, it makes GJ 887d more promising for holding on to air. The planet is also heavy, which means a lot of gravity. It would make launching rockets tricky, and it wouldn't be an easy feat to go for a walk there. But heavier gravity is also good for keeping a thick atmosphere. If it developed on the planet, it could protect the surface and trap just enough heat. Unlike some planets, our guy doesn't pass in front of its star from our point of view. That means we can't easily measure its atmosphere by seeing how the starlight filters through it. Instead, astronomers need to use the radial velocity method, which detects tiny wobbles in the star caused by the planet's gravity. We still have a lot to learn about this world that might turn into a top travel destination one day. Every year, astronomers discover new planets outside our solar system. So far, we've found over 6,000 exoplanets, planets orbiting stars other than the Sun. What interests us the most are planets that could host life, or at least have the right conditions for it. The big goal is finding stable liquid water on the surface, not frozen solid or boiling away into space. For water to stay liquid, a planet can't be too far from its star. Too far and all the water will freeze into ice. Too close and it will boil off like water on a stove. And since every star is different, each one has its own habitable zone depending on its size, temperature, and brightness. So far, telescopes around the world have found about 70 planets in a habitable zone. But only 30 of them are rocky, like Earth, where oceans might actually exist. The thing is, only rocky planets can have oceans because they have a solid surface where water can collect. Plus, such planets also have gravity, which helps keep water in liquid form. Without it, water would quickly evaporate into space or free solid. Now, having these conditions doesn't mean life is guaranteed. Venus and Mars are technically in the Sun's habitable zone, but Venus is a roasting oven and Mars is a frozen desert. Life there seems unlikely. Or take this planet, for example. This super-Earth is 20 light-years away. Astronomers spotted it in January 2025 using telescopes at ESO in Chile. At first, it sounded very promising, but the planet's orbit is very stretched out, like a long oval. That means it swings in and out of the habitable zone during its year. When it's far from its star, freezing winter lasts forever, not exactly life-friendly. But even a perfect orbit isn't always enough. In the Gliese 667c system, 22 light-years away, astronomers found 3 planets in the habitable zone. But one, its planet F, is tidally locked. One side always faces the star and is scorching hot. The other side is in permanent shadow, freezing cold. Life could only survive in a thin strip between the two regions, or if strong winds spread heat across the planet. A true habitable planet also needs protection from cosmic rays, like a magnetic field and a thick atmosphere. Otherwise, radiation from the star will fry any chance of life. Take the TRAPPIST-1 system, discovered in 2016. 3 planets orbit in the habitable zone, but TRAPPIST-1b is tidally locked, gets blasted by stellar radiation, and has no atmosphere at all. The other 2 planets might have atmospheres, but we don't know yet if they can block out harmful radiation. Red dwarf stars, small, cool, dim, and also the most common in our galaxy, make things trickier. Their habitable zones are close to the star, so any planets there get hit by strong solar flares. Our closest potential second home, Proxima Centauri b, faces this problem. Unfortunately, it doesn't transit or cross its star from Earth's point of view, so we really can't study its atmosphere or see if it can protect life. And even planets that tick all the boxes, the perfect orbit, habitable zone, atmosphere, can still be nightmarish, like Venus. A circular orbit, habitable zone, thick atmosphere, and yet it's basically an oven with crushing pressure inside. Even Earth itself isn't perfect for life everywhere. The North and South poles are freezing. The Atacama Desert is almost completely dry, so life struggles there too. That's why astronomers aren't stopping at planets in the habitable zone. They're now hunting for signs of life in the air. Certain gases can hint at life. CO2 and methane might come from biology, or they might not. Some gases, like dimethyl sulfide, are thought to come only from living things, but scientists aren't 100% sure. So, the tricky part is, how can we tell if a gas is made by life or by rocks and chemistry alone? Well, we've got new telescopes, like ESO's Extremely Large Telescope. They can give us much more detail. They could help us find more planets in the temperate zone and even reveal certain traits that would tell us if a planet is